Hi everyone, I'm David Wismer, a recent graduate of the Metis Data Science Bootcamp, and today what I want to do is show a demo of the dashboards that I've created and also go through a code review for a project that I completed during the data engineering module of the bootcamp. So for this module, we were meant to create a data pipeline that could produce an end product on a regular, ongoing basis and use automation and Hi everyone. I'm David Wismer, a recent graduate of the Metis Data Science Bootcamp. And today what I wanted to do is go through a dashboard demo and also a code review of a project that I completed for the data engineering module of the bootcamp. And for this module, we were meant to create a data pipeline that could create some sort of final project or final product rather on a regular ongoing basis using information that was automated and Hi everyone, I'm David Wismer, a recent graduate of the Metis Data Science Bootcamp, and today what I want to do is go through a code review and also a dashboard demonstration of a project that I created during the data engineering module of the bootcamp. And for this module, we were tasked with creating a data pipeline that could take in some data, manipulate it, and ultimately display it in some sort of final product on a regular ongoing basis. And for my project, I created a series of bouquet dashboards that are all centered around the state of Bitcoin. So, starting off with some code review, I want to talk about how I got the data in the first place into Postgres, and then ultimately brought it into my Python environment to do some interesting things with it. So, first we'll start with data collection. And here I am within my Metis Engineering Module repository on my GitHub. And if we go to this data folder, you'll see a variety of different modules here that are all used in the process of getting the data ready for presentation. I think the first thing that we might want to look at is this Glassnode module here. This is a pretty simple module using the Glassnode API in order to collect a variety of different on-chain metrics. These are things that are not necessarily related to just the price of Bitcoin, but also to the usage and demand of the blockchain. And then we've also got, so this Glassnode retrieve works in concert with this to get all of these different indicators. And then Google Trends I didn't actually use for this particular project, but in the future I would like to add this information to the dashboard. I did use this for a separate sentiment analysis project, however. This is an indicators module, and so what this is doing is using some Jesse.trade built-in functions and also some custom functions that I've built in order to take this price information that I have and calculate a variety of trading indicators, which I've put on the dashboard, and you'll see what these look like here in a bit. And then the pipelines, this is used for Jesse.trade to get information into my Postgres database. And then also I retrieved some information from Reddit, although you don't necessarily need to look at this for this project. This was used in the sentiment analysis project that I completed later in the bootcamp. And so with that, let's just take a look at the dashboard really quick and do a quick run through of what I've built. The first thing you'll see here is a random forest classification model predicting will the price go up or will it go down in the next 1 week period. And so this is saying as of right now, if we have up-to-date data, we've got a 27% chance of it going up according to our random forest model in the next week. Next, we see Ichimoku Cloud, and if you're an Ichimoku Cloud trader and you know what these indicators mean, then this will be very familiar to you. But if not, obviously you'll want to go get some training on this. These sets of indicators can get pretty complicated, but ultimately what it's doing is showing momentum and also some price action and dynamic levels of support and resistance. So that's what this cloud here, this blue and red line, which are called Tenkan and Kijun, they're all showing this dynamic support and resistance. And then of course we have it graphed alongside candlesticks, which show the open, close, high, and low prices for each given date. And then as we scroll down, we see trading volume information, as well as MACD, which is another momentum indicator. Down here, we have kind of a novel representation of Ichimoku Cloud featuring bullish Kumo twists and bearish Kumo twists. Moving on, the next set of indicators here is related to Bollinger Bands. And Bollinger Bands are a measure of volatility. So when we see big price moves like this, we end up getting a very large Bollinger Band, indicating that we've had some recent intense volatility. And price does tend, after these big periods of volatility, to come back to the midline in the Bollinger Band here in orange. And then when we get these tight Bollinger Bands, if they've persisted for a long time, it could be an indication that a big move might be incoming to the up or downside. That's unknown, but you need to be kind of preparing for those big moves when Bollinger Bands are tight for long periods of time. And again, here we've got trading volume, and this is RSI, Relative Strength Index, another momentum indicator that's very popular. And again, here down at the bottom, I have some novel representations of Bollinger Bands, both in terms of the Bollinger Band size versus the closing price, and then also the price position within the Bollinger Band, just kind of shown in a different, kind of more consistent way that might be easier to read. Next, we've got what are called on-chain metrics. These are those things that are coming from Glassnode. And what you see here is, rather than graphing price, which you see in these black lines alongside the metric, the on-chain metric is instead represented in a color code. And let's, instead of showing this shorter period, let's show all of the data that we have. It's a little easier to see that way. So when we do look at all of the data, for instance, with NUPL, or net unrealized profit and loss, which is a very common measure of sentiment in the market, what we see is that when we're in green and blue, this means that a lot of traders out there are in the profit. And what it means is that we need to be careful, because there could be a correction coming, a downturn in the price, because everybody is now in the belief and denial, or euphoria and greed stage. And so people aren't selling, and that's generally a recipe for quick correction. And what we see here is when we get into the red, that's when everybody's selling off. There's what's called capitulation, generally a good time to buy. And then as we scroll down, we'll see some other on-chain metrics. This is stock to flow deflection. So stock to flow is a valuation method for Bitcoin. And then this is market to thermocap. When we get these kind of hyperbolic moves in price, generally it tells us, all right, we need to be careful here, consider selling. Percent supply and profit, which is actually an input to net unrealized profit and loss. And then also Puel multiple. These are things you can all look into, but the methodology here is consistent. We're kind of showing this color coding so that you can kind of look back and say, all right, in which colors was it time to sell? When was it time to buy? Just as kind of a way to collect indicators and build a case on what's going to happen with Bitcoin. The last thing I want to show are divergences. And so what we're looking at here, it'll be easier to see if we look at a larger look back period. But what we're seeing is the slope of the regression line for price in blue versus some other metric, which will either be volume, RSI, or MACD. These are common indicators to look at in conjunction with price. So let's look at price versus volume. Here, for instance, on the 8th of July in 2020, we see a positive regression slope for price. So price is trending upward over this 120-day period, which is not necessarily useful, but might be useful more on probably like a 30-day basis. And then we see a negative regression slope for volume during that time. And so what that's saying is that price is trending up, volume's trending down. And generally when we have that divergence, it is an indication that price could be topping out, and you might want to use that in consideration on whether to sell. And an easier way to probably look at this is here. So let's look at this over just a 30-day period. And what we see is that we've got price, first of all, here graphed in white, and then the green and red are indications of bullish or bearish divergence historically. And so here we've had this long period of bearish divergence on a 30-day look back, meaning that over the past 30 days, the regression slopes for volume and price are such that it's saying we're going to see a downturn in price. And it was obviously ignored for quite some time. Price did climb, but then it started to turn over, and then we had some regression back to, we had a big correction here. And then it's back to green. Maybe it's time to consider buying again. It's all a collection of indicators. No one indicator can tell the story, but through this entire set of dashboards, you can start to paint a picture and become more confident in one way or the other on what's going to happen with Bitcoin prices. So with that, I would like to go through some of the code behind this set of dashboards. And the first thing I'll do is just quickly touch on the random forest model. So as I mentioned, the random forest model kind of is what it is. If some brand new budding data scientist could build a well-functioning price prediction model for Bitcoin, he probably wouldn't be in a boot camp to learn about data science in the first place. He might be off working at some very profitable company. In any case, I did take my shot here, and what I did was I built a scikit-learn model using random forest to classify whether price would go up or down. Obviously, I needed to import some things, a lot of things related to scikit-learn, the random forest classifier, train test split, confusion matrices were built in this workbook as well, scoring accuracy and classification, and then pre-processing the data with min-max scaler and standard scaler as well, and also imported some custom functions, interaction module for interacting with my Postgres database, etc. So here first I needed to import some data, and that's what you're seeing here, all of these interactions with my Postgres database. I have a separate module where you can check out how that looks. And then I needed to add some additional columns. So this is feature engineering, things like, okay, we've got our transactions, but maybe what we want to do is look at transactions over a 30-day period rather than just the transaction fees for a single day. So, I need to do a rolling calculation of that, for instance. Probably want to do that with some other Glassstone metrics as well. There's all sorts of feature engineering that needs to happen. I wanted to try out a whole bunch of different things and see what sticks with the random forest classification model. Obviously, I'll also need to do a lot of merging of information because I had several different data sources and my Postgres tables were pretty numerous. So I needed to bring all of that information in and merge it all together in order to feed it to the classification model. So that's the code you're seeing here. And then next I was doing some EDA, examining data, searching for correlation. And that's what you'll see here is a lot of these heat maps looking at, okay, for Bollinger Band related metrics, where are the correlations and how do they correlate with price change over 1, 3, 7, 15, and 30 days. So which Bollinger Band metrics are likely to be most useful in the model. And I did this for a variety of different areas, Ichimoku Cloud, all of the MACD and Glassnode information. Any metric that I considered using in this model ultimately was put in here. So here what we're seeing is regression correlation matrix. So this is looking at for instance, the closing price regression normalized over the prior 3 days, and how did it correlate with all of these other different things we've got going on, because I wanted to look at how does the regression slope of volume, trading volume, or MACD, or RSI, or price itself, how does that interact with or correlate with rather actual price changes in the future. Ultimately, I took all of this and I ended up doing kind of a brute force feature reduction. And so that's what you see here. And I had all of these features that I'd considered. And then I needed to get down to what are the final features in my random forest model going to be. And so to do so, I ran both sequential forward selection and sequential backward selection. So as you can read here, sequential forward selection works by finding the first feature that has the single most predictive capability for the model. And so, okay, we set that one aside. We're going to use this in our model. Then we run through all the features again and say, okay, well, which feature when combined with this one that we've already set aside has the best predictive capability? Okay, we find that one, we set it aside. We repeat that process, ordering all of our features in terms of importance. And for sequential backward selection, it's kind of the opposite. We want to remove features one at a time. We want to remove the one that is going to be least useful. So we run through, we look at all of our features. Then we subtract one, each and every single one, and we move forward with the model with which has removed the feature that had the least impact, or in any case, the one that had the worst score in terms of accuracy of all of the models tested. We complete that process until we get down to the very end. We're left with a single feature, but ultimately what we're really left with is a list of features in terms of importance to our model. And then looking at sequential forward and backward selection, we can see, okay, combining these together, which was the single best model in terms of predictive capability. So in order to do this, you've got a variety of things that need to happen. Here's a train test split function that I built. This is a sequential backward function that I built, which returns the backward order. It also returns the sorted combos in a data frame, so you can kind of inspect what are the best combinations and what were the accuracy scores of those. And then, of course, I have the sequential forward function as well. And then here we've got a function that accepts the features and a population, returns a data frame with all combinations of the features. Data frame is sort of the accuracy score for each feature combination. These are all things that are used just ultimately in determining what are the best feature combinations to be used in the model. And then from there, here you can see at the bottom, I've got these different favorites. So one is looking at, I picked out intuitive features that made sense to me, having studied trading indicators across, in the past. What do I think makes the most sense? Picking some things from Ichimoku Cloud, for instance, some Glassnode metrics that I know to be very popular, and I put them all into a bucket. And then I did forward and backward selection. Ultimately, this is what came out. This was the best performing of the models. And then this one is all features. So this is the result of putting every single feature I had into the model. And then here, this is kind of a combined favorite. So what I did here was I took all of the intuitive favorite features and the all features favorite. I took both of these lists, combined them, and ran another sequential forward and backward. And then this was the best from that. So these are kind of the three top models from the testing of all of the different random forest combinations in terms of features. From there, I did parameter tuning on the model. So I built kind of a grid search type of function here that accepts different lists of potential parameters, tests them all out, and then tells me which ones are the best in terms of score. And down here, you'll see these different parameter lists that were tested. And ultimately, I established final models with the intuitive information, the ones that I thought were good features, all features, and then the combined of my intuitive and all features favorites. Then from there, obviously need to save your things, pickle them. And then I did some model evaluation using confusion matrices. So this is a function that I built to, or maybe I stole it from somewhere, to display a confusion matrix. And let's take a look at what those look like. I already went through this on a PowerPoint presentation that I've also posted to YouTube, so you can see that there as well. But here we're seeing the intuitive features model, the all features model, and then ultimately the combined features model. I'll just go through this I'll go through this one here, this all features model, because really this is the one that should be the best. I didn't exclude anything that I didn't think should be there. I didn't do any extra steps. I just fed it every single feature and said, okay, random forest, tell me what you think is the best. And with this model, what we see is really good recall, not so good precision, not so good specificity. Accuracy is at 70%, so it's correct 70% of the time. It's easier if you just kind of go through the matrix. So let's start on the left here. This is normalized by actual, which means that the rows add up to 100%. And so true classification is on this left here. So what this means in this bottom right corner, for instance, is that when it truly was a sell opportunity, meaning that the price went down in the next week, the model said to sell 94% of the time. So the model was right when it was time to sell generally. But if you look here in the upper right corner, when the right thing to do was to buy, meaning that price went up in the next week, the model also said to sell 68% of the time. So that's not so good. The model trends towards telling you to sell, it seems. And if we flip over here to the right, now the columns add up to 100%, so normalized by prediction. What we see here in the bottom right corner is that 68% of the time the model said to sell, it was correct. And 78% of the time the model said to buy, it was correct. So what do we think here? It seems like when the model says to buy, it probably is a good thing to do. But the model obviously is biased toward telling traders to sell. And when it does say to sell, you need to take it with a grain of salt. Ultimately, this model could simply not be used on its own. It's at best another data point amongst a series of data points that we've shown on the dashboards. And I think that about covers what we have here in this model. There's more stuff down here for feature importance, some ROC curves, but I won't get into that now. So that covers the random forest classification. Let's also look at some bokeh code. So this is going to be very messy. This was built in a 2-week module. Some of it really probably should have been modularized in a different way. We probably should have pulled out certain indicator calculations that are happening within this and put them into a separate model that could have been done during the data load rather than during the presentation of the dashboards. In any case, there's a lot you can use in here. If you want to understand how to build, all of these different things, how to use radio buttons, how to add a dotted line across here, how to do these annotated color coding, or even just here on the Ichimoku cloud, every single shape, line, color fill that you see had to be coded on the bokeh dashboard or within the bokeh dashboard script. So here's somewhere where you can look. If you like something you see within the dashboard demo, you can look here and see how did I make that. So let's just scroll through and take a look. Everything is contained essentially within this one big modified doc function, and then at the very end, what you'll see is down here, this is how we display the documentation. So this is tricky. It was tricky to figure this out. There are some resources that you can find on the internet, but feel free to reach out if you need any help here. We obviously need to pass in some data frames. This will be the data for the bokeh dashboards, but this is kind of how it ultimately is displayed. But let's just take a look at a couple of these somewhat at random. So for instance, the on-chain information. Just as a reminder, the on-chain information is all of this color coding that we've got alongside price for on-chain metrics that we've got from glassnode.com. And what we see is, first I needed to set up a color dictionary. I wanted to be able to refer to these colors, and then it would use a hex code to pick that actual color. The Glassnode dictionary here, these are all of the different metrics: net unrealized profit loss, stock to flow deflection, etc. These are the legends. So we'll be referring to this throughout the code here. And then this is showing the graph name to kind of like the actual column name within our database. We'll see why that becomes important. So what do we need to do? We need to plot the Glassnode information. So we need to like set up a figure. We've got our graph. The figure is going to have a title, which we're going to have passed in using a dictionary. The location is going to be on the left. We're going to have a date time axis. It's going to be a log style y-axis with a specified height and width. And we're going to do some things to fix up our how the graph looks in terms of the grid and the axes. And let's see. So here we're kind of getting to the meat of it. We need to set up a lower, an upper, and a color. And what this is doing is saying we've got a lower bound, an upper bound, and the color of the bar. So here, for instance, this one big green bar that you see is going to have a lower bound in terms of a date, an upper bound in terms of a date, and then what the color is going to be. And I won't get into the nitty-gritty of how that was calculated, but if you're trying to do something similar to this, you can take a look at this and you can reach out to me if you need to get any advice on how I went about it. What else is tricky? Divergences, this is ultimately just kind of a couple of lines on a graph, but there are also some things happening with hovering. So tooltips is another thing that was a little tricky to figure out, but you'll see a lot of that happening throughout here. And let's see if we can find where that tooltip information is happening right here. Add tooltips is a functionality obviously within Bokeh, or actually maybe it's not. Maybe I built that because I'm referring to add tooltips quite a bit. It's probably somewhere up here at the top. Yes, it's a little custom function for adding the tooltips. You need to tell it which graph you're going to do. It needs renderers and the tips themselves. So if you need to add tooltips, you can look here as well. I don't want to go too much into the code on Bokeh, but there's a lot happening in here if you need to understand, or see an example on how to build colored bars for candles, for instance, or shaded areas between two lines, for instance, with this light purple between these two dark purple lines. Then you can use my GitHub code to as a starting place at least. Okay. Not sure there's too much else to show other than to say that I have a number of write-ups on here. I've got my presentation slides as well as my project write-up and kind of a full write-up on the project down here as well. If you have any questions, feel free to reach out. I'd be happy to help. Thanks.